Good morning, everyone. Welcome to this class of week 7, Math 13218, Advanced Application of Mathematics. Today, we will continue our discussion of second order constant coefficient inhomogeneous linear ordinary differential equation. So last week, we started this topic. We are continuing our discussion in the same topic with some more cases and variation, right? What I expect those who are attending or watching this recording, please familiarize yourself with all the term. That is, what do you mean by this second order constant coefficient inhomogeneous linear ODE? There is so many terms here and a lot of detail in each of it, right? So if you break it down, we are talking about ODE. I have said it, I'll say it again, so it doesn't look like an alien word. ODE, that is ordinary differential equation. So it only contains the term of ddx, ddt, not the partial one, right? Again, I'm not going to describe the difference because we are not touching partial. So it doesn't make sense to talk about it, right? Linear is they are not multiplied together, like a linear equation, right? You won't have a square of them, not at least here. Inhomogeneous, so with the homogeneous linear ODE, the right-hand term is 0. Up here, it's not 0. It's some function, some constant, right? Constant coefficient, that is the multiple of this differential term. So when you're talking about dy by dx or d2y by dx2, its multiple will be 2, 3, 5, not like x squared plus 1, right? Not a function of x. And second order, that means we are talking about d2y by dx2, right? Okay. Those who are watching the recording, please ensure you are familiar with last week's content. If not, revisit it before you go for this. If you're not sure what we covered last week, you kind of struggle a bit, right? So it's better if you're watching the recording, pause it here and go back to last week 6 content and review them, because the example we will discuss will be 80% similar to what we have done with a bit of variation, right? It's a special cases of what we discussed last week. So if you are familiar with last week content, if you know what happened there, then today is almost done. In terms of the final exam point of view, before I start today's content, I was chatting with some of the students when they were in the consultation time. So we got almost 9 weeks of content, and it's a 40 marks. More detail will follow as we go closer to the term, but those are preparing from now and have that mindset. So almost every week will carry 4 marks weightage. It doesn't mean that every week content will be there, because some modeling question will contain higher weightage, So if they are higher weighted, obviously, I'll have to skip one of the week's content or have a very minor topic covered for that, right? But on an average, you can assume that every week's topic is about 3-4 marks, okay? When I say week 7's content is based on week 6, so if you covered both this week, so you will definitely have a couple of marks for both this week. It could be 4-5 marks, could be more, could be less. There is no set deadline that every week is 3 or 4 marks, but just give it as a general guide, keep focusing on week by week content. Yeah, right. So this is what I mean by second order constant coefficient inhomogeneous linear ODE. So second order d2y by dx2, constant coefficients. So the coefficients are constant, a and b are constant here, right? Inhomogeneous, that means the right hand side is not 0. That's inhomogeneous. Linear ODEs, so dy by dx and d2y by dx2, they are not multiplied together. You won't have something like that. Ordinary differential equation, so there is no term called the partial differential equation here. So that's when the right hand side is some function of x, that's called inhomogeneous. But when it's made equal to 0, we call it corresponding homogeneous differential equation. Okay. Just to recall from your memory that we will use this to make the corresponding equation, auxiliary equation, and then we'll talk about the root of that equation. Right? We call it characteristic equation as well. Okay. Right. So These are the steps, which is pretty much similar to what we discussed last week. Get the general solution of its corresponding homogeneous equation. So we mean this corresponding homogeneous equation by its characteristic equation. Okay. Then get the particular solution yp related to fx. That's your second step. This is where it gets a bit tricky, but tricky or not, we will do it. And even if you can't do it in the exam or anywhere, what I would request is, just do what you can, because every steps will carry some weightage. Yeah. So if you have, few steps done correctly, you'll get half mark, 1 mark, and everything helps to boost your score, right? Then YH, which is the homogeneous for this one, and YP, YH plus YP added together, it forms the general solution. We call it YG. And finally, if there are any initial condition, we will determine our constant that we have, put into our YH. Okay? This is similar to what we discussed last week, but we had some restriction in the condition here. Now, obviously, we don't expect you to memorize this. I mean, if you can, awesome, but it's non-essential stuff, and I'm sure it will confuse you if you try to memorize everything. So keep it in your formula sheet, right? Because this is an open book exam, so any printed material, handwritten notes can be taken into the exam, right? So you can include this. You can also print your PPT, highlight some of the section that you need, condense your PPT. Otherwise, you're talking about like 400-500 pages. So when you print your PPT or PDF PPT, make sure it's a multiple pages, like a handout format, like one in 4 slides in one or 6 slides in one. So you can really take the condensed material with you, not like the whole thing, Right. I'm not talking about all of them now, but the left-hand side is important to identify. So this is like a polynomial, right? Polynomial could be the highest power m, or a combination x power m minus 2, x square x, and everything. Cos or sine or combination. Exponential with constant a. Exponential with cos or sine or combination. And exponential with x power and some constant. Constant could be 1 as well. And then how you treat them, the corresponding YP. YH, very easy, similar to what we had done in week 5, 6, both, right? Week 5, we are only talking about YH. There is no YP. And then week 6, we started introducing YP as well. Okay? Right, so let's look at an example. So every now and then, I'll come back to this slide. I have taken a portion of the slide, so we are not looking at everything and making ourselves confused. So first job, you'll have to realize is second order, right? Because when you see a question in the exam, it won't specify the weeks, won't specify the method. It's your job to have a clear bifurcation in each of the methods, right? The second order, inhomogeneous, right-hand side 6. So that belongs to this constant, right? Now, you will have yp is equal to ax if the characteristic equation formed from this differential equation has only one root as 0, has one root as 0. Obviously, both of them can't be 0. Otherwise, that's not a characteristic equation. So let's talk about characteristic equation. So first step, it's a second order. So we will write it, first of all, in a homogeneous way. Okay. Now, from here, you form its characteristic equation. It's a second derivative. So r squared 3 times r is 0. We try to factorize it. Take r common, r minus 3. The roots are r is equal to 0, r is equal to 3. Now, read this line. If the characteristic equation has 1, 0 root, we do have 1, 0 root. If it's not, if it's a constant, then go to week 6 content, right? Where I nicely bifurcated everything and follow what we done there. Okay, cool. So our First of all, we haven't stopped YH. We have to write about YH first. So this is from week 5, right? What is your YH? C1 e raised to 0x, C2 e raised to 3x. Write it nicely. E power 0 is 0. Sorry, 1, my bad. C2 e raised to 3x. That's all about YH. Now, when it comes to YP, only there you will have to worry about this extra table and what happens in special cases, right? So our characteristic equation has 0 as a root. If that happens, our YP, which is our second step, will be of the form AX. Okay, so step 2. YP will be AX, right? That's your YP. Then we talk about YP dash. Remember what I said last week? YP, YP dash, YH, YG, all these things, they are symbols to forget, right? But when you are substituting the value Y dash, what you obtain should go into the original question. AX differentiation is A and YP double dash constant differentiation is 0. Our question says Y double dash 3y dash is 6. Plug all the values here. This and this one. So 0 minus 3a is 6. That gives you a is equal to minus 2. And if a is minus 2, your yp is minus 2x. Right? And finally, step 3, which is the general solution yg. It is yh plus yp, which I'll do it here. YG, YH. If you don't remember, go back. This is your YH. C1 plus C2 e raised to 3x plus, sorry, it's a minus, so we'll keep the minus 2x. This is my final YG or the general solution. Okay, we will go for step 4. If there is initial condition that y of 0 is this, y dash 0 is this, then in order to find C1 and C2, we need 2 conditions, right? And we will use it then, not here. Okay, but that's an easy example to start with. Right, we keep going. We talk about the next question. Okay. Y double dash minus 5y dash is equal to something of x. If you go to the table here, xm or polynomial in x of degree m, so whatever power, right? You get some power, okay? Then yp is x times pmx if c has a 0 root. If you look at your c, the characteristic equation, it has a 0 root, right? So your yp is x pmx. So you multiply your polynomial with x. Okay, first step first, S1, step 1, which is the corresponding homogeneous equation. Right. So step 1 is corresponding homogeneous equation. Y double dash minus 5y dash is 0. From here, you will write r square minus 5r as 0. Right. From here, you will have r and r minus 5 as 0. R is 0 and r is equal to 5. Your yh c1 e raised to 0x. That is c1 plus c2 e raised to 5x, which is my YH. First step clear. Okay, and now we worry about second step, and there all this table and everything will come in place. Step 2. What's that one? If CE, the characteristic equation, has 1 0 root. Yes, it has 1 0 root. So what should be your YP? Is X PMX. Now look at the symbols. Here we are talking about M. This is the same M. Okay. So what is the x power m? Is here. X square is your x power m. Right? That means m is 2. So you are talking about your yp as xp2x, a polynomial in x. That is a quadratic equation. How do you write it? X a2x squared a1x plus a0. This is my yp. If you want to multiply it, so your yp will be a2x3, right? a1x squared and a0x. This is your yp. Okay. Now what we will do? We will obtain the value of y double dash, y dash, plug it in the original equation to obtain the value of a2, a1, and a0. Right. I write yp again. That is a2x3, a1x squared, and a0x. Yp dash, that is 3 a2x squared, 2a1x, and a0. We also need the double dash, 6a2x, 2a1. Now, the question we have that says y double dash minus 5y dash is equal to 15x squared plus 4x minus 7. We'll have to plug the value of y double dash, y dash in this equation. Equate, that means compare the left and right side. Okay. Y double dash. 6a2x plus 2a1. 3a2x squared, 2a1x plus a0 is equal to 15x squared, 4x minus 7. Okay. What we will do is compare the x square, x, and constant. Prior to that, we will write or collect them in the same form. Okay. So this is your x square term. 1 and 2 is your x term. And this dotted line here, that's your constant term. Okay, we compare and first of all collect it, and then we compare the left and right part. Okay. Right. So let's start with x squared term, that is minus 15 a2x squared plus we got 6a2 minus 10a1x minus 5a0. Sorry, we should have written plus 2a1. 2a1 minus 5a0 is equal to 15x squared, 4x minus 7. Right? So then we'll begin the comparison. So minus 15 will be compared here. 6a2 is 4. And this 2a1 minus 5a0 will be our 7. Okay. Right. So on comparing, what we will get? So minus 15a2 is 15. That will give you your a2 is minus 1. Great, we got one of them, right? What was the other one? 6a2 minus 10a1. That was one thing. That was equivalent to 4. 6a2, so minus 6 minus 10a1 is 4. So minus 10a1 is 10. a1 is minus 1. Wow, that's also minus 1. Good. Finally, you have to be extra careful here, because if your A2 is wrong, you don't equate it well, A2 is wrong, is a chain reaction. So the error will be multiplied, will grow. So your A1 will be wrong, your A0 will be wrong. And if you're talking about all the initial condition, everything, like the error will be really big, right? So extra careful when you are calculating, every step. Okay. Finally, we got 2a1 minus 5a0. That is equal to minus 7. Okay, so 2a1 minus plus 5 is minus 7. My bad, sorry. Minus 2 minus 5a0 is like that. So minus 5a0 is minus 5 and a0 is 1. Awesome. Right? I like to split the screen and do everything here so I don't flip lot of slides or pages. And that way, at least in my case, I reduce any possible error, right? Cool. So we got all of them, A0, A1, A2. So the next step is to write them. So your YP, which was A3, sorry. Okay. A2x3, A1x square, and A0x. So your YP A2, which is minus x cube, sorry, not square, minus x squared plus x. This is your YP. Okay. So we got our YH, we got our YP. If you want, we can just summarize the final step as 3, which is the combination of YH and YP. Just write it down. This was C1, C2 e raised to 5x minus x3 minus x squared plus x. This is my y or yg. Okay. Cool. So since we have covered first two example, if we go back here to the table, so I should have brought table and more slides. Yeah, so we covered the constant, we covered the polynomial. Now we talk about cos or sine or a combination, right? That's our next example. Okay. Right. So y double dash plus y is equal to 2 cos x. This case will apply. First of all, identifying that this is the case is important. So again, you should start like I was explaining at the beginning of the session. First of all is a double order. So that's a second order, double derivatives, so second order inhomogeneous. So the right-hand side is non-zero. That's inhomogeneous. Obviously, we are talking about ODE, and then realizing is a cosine sign on the right-hand side. So that's a cos or sine or combination that is ticked. And then, of course, YP is this form. But if one of the roots is plus or minus, the roots of characteristic equation are plus or minus in, that is alpha is 0 and beta is n, then you can apply this chosen YP. First thing first, let's start with S1. Whatever number of marks this question is, even if you do first step, that is your homogeneous equation, you will get at least some marks. So my blunt, clear, upfront advice is don't skip any question. I cannot give you even a half mark, though I am willing, though I wanted to help, if it is left blank. Right? Have some steps and leave it to me whether it's right or wrong. That's my job, right? Whether you'll be given any half or 1 marks, that's my job. But you do your part of writing some steps which you feel is correct. Okay? Right. Step 1. Okay, step 1. What we will do in step 1, we'll talk about the homogeneous differential equation, corresponding homogeneous, right? So we will talk about y double dash plus y is equal to 0, right? From here, we got r square plus 0 r plus 1 is 0. That is r square plus 1 is 0. Recall your last term. R square is -1. R is equal to plus or minus I. Whatever you learned last term, sorry, is not in vain. Especially in algebra, complex vector, we are not covering here too much, but definitely those two. The previous question which we solved by back substitution, you can easily form a nice descent metric, right? You got three equations to compare, isn't it? Minus 15a2 is 15, right? 6a2 minus 10a1 is 4, right? And then you got 2a1, the third bit, right? This thing, 6a2 minus 10a1 is 4, 2a1 minus 5a0 is -7. You can easily equate and make three equation and go for Gauss elimination, Gaussian elimination, A inverse metric, right? Because it's 3 by 3 equation. But that's not required if you can do it with an easy way. But if there is no easy way, obviously we'll have to do it from our acquired known method, which we learned last time, right? Okay. So R is equal to plus or minus IN. Now remember, everything is symbolic. This is cos nx sin nx. This is cos x, right? So cos nx is your cos x. So your n is 1. The root is plus or minus in. So your n is 1. That's what it is. Alpha is 0 and beta is n. N is 1, right? Alpha 0, right? This is 0 plus or minus 1i. That matches. So your choice of yp will be that. But again, before we go to yp, we have to finish our yh. Okay, so yh is e raised to alpha x. Remember, alpha is 0, beta is 1. I'll write the whole thing just to refresh our memory. C1 cos beta x plus C2. This is from the earlier sessions. E raised to 0x, which is obviously 1. I'll write it here. C1 cos x, C2 sin x. And finally, once simplify your yh will be C1 cos plus C2 sin x. That's your yh, step 1. Like I said, do what you can. Even if you messed up some yp, you know the correct form from your literature, from the material you have in a classroom. That's what matters, right? Okay, step 2. Since we have already analyzed whether this is correct or not, I'm simply going to write it. But if you haven't, spend your time in analyzing that this is the correct YP, right? Okay, so step 2. My YP, I'll write it as it is first of all. X, A cos nx plus B sin X, A cos nx plus B sin X. Okay, but n is 1. So my YP will be how would I find? Okay, leave the x over there. It's fine. X A cos plus B sin. This is my YP. What is our next step? See, from here is all mechanical step, like literally mechanical step. So you're doing it step by step, but this is easy part from here. It's just analyzing which YP will be correct YP, which form of YP will be correct. Then what you do is normal standard process. You obtain Y dash, Y double dash, whatever your original question has, plug it in, compare, equate the equation, get your constants, in this instance, A and B. Last question was A0, A1, A2. Obtain that, plug it back in a YP. You got your YP, you already have your YH, add them if there is initial condition, which is none here. In this case, if there is, you go for step 4, which is a bit longer, but doable. Okay, right. The question needs us Y double dash, obviously. So we talk about YP dash. In order to have double dash, we need to have first derivative, right? Then only we can talk about double derivative. Right. So this is a UV formula, UV dash, right? What is UV dash? I'll write it down for your recall. UV dash, U dash V. Differentiation of one of them while the other is at it is and swap the order, right? This is my U, this is my V, right? If you want, I can write a few more steps. So U dash, I'll leave the U as it is, A cos X, B sin X dash, plus derivative of U and the other term as it is, right? Therefore, your YP dash X, A cos differentiation is minus A sine. A is as it is a constant with multiple. And cos differentiation is minus sine. Sine differentiation is cos. X dash, which is 1. So simply this is A cos X plus B sine X. Okay. Now YP double dash. Okay. So again, X as it is. Differentiation of minus A sine plus B cos X dash. And the bracket as it is. Plus differentiation of A cos plus B sine X. I haven't differentiated, I just wrote the UV dash form. Okay. And therefore, my YP double dash, X as it is, A minus A sine will be minus A cos. This is minus B sine. Right? X dash will be 1. So that will be minus A sine plus B cos. See, when you're flipping the page, changing over the slide, please observe it carefully. All right? A cos plus B sine derivative. A cos will be minus A sine X. B sine will be B cos X. You can combine it. As you can see, they are the same. Right. So your YP double dash will be X minus A cos X minus B sine X plus 2 times minus A sine X and B cos X. This is my YP double dash. Looks horrible? Huh? That's right. Y double dash plus Y is equal to 2 cos X. Y double dash, that is here. So since you are comparing it with only cos, can I write a 0 sign here? And when you plug in YP double dash, kindly separate cos and sine, because this is what you will be doing, right? So I got 2 cos term here. There is a cos term, there is a cos term, this is sine term, this is sine term. I'll write them by separating it, okay? Right. So that one will be minus AX from here plus 2B cos X, XB minus 2A sin X. This is for YP double dash. Okay. I still have Y. What is my Y? X, A cos X plus B sin X, right? So I'll write AX cos plus BX sin is 2 cos X, 0 sin X. I would strongly encourage to write 0 sin X so you know that you are equating it to 0. If you don't write 0 sin X, there's only a cos term. Some of you might struggle, especially in a stressful situation. You got one of the question wrong, you're running out of time, you feel like, oh, what is happening? And stress builds up, right? So just develop that habit of, if you're equating it, write 0 term. Same in a quadratic equation, right? If you got an x term on the left, but nothing on the right, then write 0x. Yeah. One more combining. I'll combine this before I compare. So that will be minus ax plus 2b plus axc. Axx is gone. So you're really making it easier. Yeah. Minus xb or bx if you want. That's right, bx, because that's more standard way of writing. Bx 2a plus bx sine x is equal to 2 cos x 0 sine. As you can see, axx is gone, bx is gone. So if I equate it, I will get 2b is 2 and minus 2a as 0. That means a is 0 and b is 1. I got my a and b. And that's what we wanted, isn't it? Right? Finally, our yp, which was xa cos x and b sine x. Therefore, your yp, a being 0, that will only leave b is 1, x sine x. That's my yp. Right? And finally, your step 3, which is writing the general solution, right? That is yg is equal to yh plus yp. Therefore, yh was c1 cos plus c2 sine x plus x sine x. It's a funny thing to observe here. The question or the differential equation had 2 cos. So we might expect, oh, the solution yp should contain some cos term, but your yp contains only sine term. As you can see, it's only sine, no cos. Strange enough, right? Cool. So that covers our three of the example, right? Cool. So we covered three cases of second order inhomogeneous constant coefficient ODEs. We move on and cover the rest of the three cases, right? Cool. So what we will make sure is to keep referring to the table and following the same approach. Okay? Right. So first of all, looking at the question, when you look at the question, ask yourself, what do I know about this, right? So its second order is inhomogeneous. Obviously, we'll talk about linear ODEs, so that's fine. But the right-hand side is a particular function that can be formed from the set tables, a e raised to lambda x. Our lambda is -1, a is 4. A is fine. Constant A doesn't worry us, right? But we will use this choice of yp if your n is 1, right? R1 and R2, and we'll use n is equal to 1. If R1 is different from R2 and lambda is either one of them, and we'll use n is equal to 2 if lambda is similar to both of them, not just one of them. But yp is in the second step. First step first. Let's talk about yh. Okay. So step 1. The corresponding characteristic equation, you need to write or at least familiarize yourself with the name, correct naming convention. So when you read a book, when you're talking with someone, it's makes sense. It's the language that everyone understands, right? Cool. So we'll write y double dash minus 2y dash minus 3y is 0. Its corresponding equation is r squared. Sorry, write it here. R squared minus 2r minus 3 is 0. R minus 3, r plus 1. R is equal to 3, R is equal to minus 1. Right? So from here, we will get our y at is c1 e raised to minus x, c2 e raised to 3x. That's my y edge. Great. Now, you go back here. What is your lambda here? So our lambda is minus 1. Is it similar to, you can call it R1 and R2 if you like. Yeah. Is lambda similar to R1 or R2? Yes, lambda is equal to minus 1. Lambda is similar to R2. At the same time, lambda is not the same as R1. So it's matching the first part, not the second one. Okay, and therefore we will choose our n is equal to 1. The moment I replace my n is equal to 1, my yp will be ax e raised to minus x. Okay, so that's our step 2, right? So step 2, our yp, as we know, x power n e raised to lambda x, n will be 1. So this will be ax e raised to minus x. That's our yp. Once we got our yp, job done. My job is done. We go for y dash, we go for y double dash, plug it back in the original question, compare the left and right. Pretty much same thing that we have been doing last week and all the earlier 3 examples today. Right. So I'll write yp here again. Yp will be ax e raised to minus x. Okay. What we need with this y dash, y double dash, we want to plug in this equation, right? In the given equation. So y dash. Okay. This is u and v again, right? A is constant, doesn't vary us. So x dash e raised to minus x as it is. Ax e raised to minus x differentiation. So a e raised to minus x minus ax e raised to minus x. Differentiation of e raised to minus x is minus e raised to minus x. Okay. Now the second derivative, y double dash. This will be minus e raised to minus x minus a e raised to minus x minus minus plus ax e raised to minus. If you need to insert one more step, please do it. Right? After simplifying, I can say minus 2a e raised to minus x plus ax e raised to minus x. This is my y double dash. Now the equation I had is y double dash minus 2y dash plus 3y is equal to 4 e raised to minus x. Plug everything here. Okay. Again, be ultra careful when you do it. Okay. Y double dash. So we will have minus 2a e raised to minus x plus ax e raised to x. That's our y double dash minus 2 times y dash. What is our y dash? Minus a e raised to x minus ax e raised to minus x. Right? That's our y dash. What's our y? Ax e raised to minus x. 3 times ax e raised to minus x equals to 4 e raised to minus x. As you can see, everything has e power minus x. We keep it outside. So this will leave us minus 2a, right? Plus ax minus 2a plus 2ax plus 3ax is equal to 4 plus 0x e raised to minus x. We simplify the left-hand side. As I said, please insert 0x so your comparison becomes a lot easy. You don't have to because that thing gets cancelled or something. But anyway, we'll find out soon. Right. What this one is simplified to? Did I messed up the plus minus sign? Is it minus 3y plus 3y? Minus 3y. That's what I thought. Okay, so that's a minus. That's a minus. So that's gone. So the 0x is not required. Anyway, so minus 4a is 4e raised to minus x. Therefore, minus 4a is 4, leaving you a is equal to minus 1. And therefore, your yp, which was ax e raised to minus x, will turn out to be yp is equal to minus x e raised to x. All right, step 3. What is our step 3? yg equal to yh plus yp. yh was c1 e raised to 3x, c2 e raised to minus x. Doesn't matter where you write c1, c2. It's all the same. Minus x e raised to x. This is my y. Okay. Now, it's not given as a part of the question, but what if you had some initial condition, right? So let's extend this response to some additional condition. What if we had some additional condition? So let's pick up some additional condition and write him in blue. So it's an extra part, not a part of the question. What if we had x additional condition? Y of 0 is 1 and y dash 0 is 2, right? Okay, so we'll have to differentiate from here. Y of 0 is 2, right? Let's get some equation from here. So y of 0 is 1. Therefore, 1 is equal to c1 plus c2 minus 0. So we got our first equation, c1 plus c2 as 1. Okay. Now the second equation, you have to differentiate it. So y dash 3c1 e raised to 3x minus c2 e raised to minus x. Product rule over here. E raised to x plus x e raised to minus x. We got y dash 0 is 2. Therefore, 2 is equal to 3c1 minus c2 minus 1 plus 0. Once you simplify it, 3c1 minus c2 is 3, right? And then you got two equations, okay? You solve it like you can do it mentally. You can do it on a piece of paper, adding them. C2 goes 4c1 is 4, right? After solving, you get your c1 as 1. If your c1 is 1, your c2 is 0. Got your c1 and c2, plug it back up here. Your particular solution, that's for particular solution. C2 is gone and C1 is 1. So you got e raised to 3x minus x e raised to minus x. That's your nice and decent YG. Okay. So again, the particular condition we're not given as a part of question. Just add it here to see how that would look. Awesome. So we got two more examples to go through. The next one is y double dash minus 2y dash plus y is equal to 0 is equal to 6x e raised to x, right? And then again, we'll go for, there's a combination of x and e power x, but we'll have to follow what's given here. Okay. If you see the difference between them, I'll go to the main chart for a sec. This one, right? They both look similar. but they are different in a way. This is A and E. This is AE and E, AX and E. And therefore, your polynomial will change drastically. This was YP, AX and lambda, E power lambda X. This is A, X power N, PMX. PMX is introduced because of this X power N term, right? Why? Because whenever there is an X power M term, you are talking about PMX. So this is kind of, should get clear in your mind. If it is the constant times exponential, we are talking about constant X and E power X. The moment we introduce X power something in the form of YX, we get another PX. Why? Because X power M is corresponding to PMX, right? So this is how it should be understood. Okay, right. Let's go to this example and make it more clear, right? So follow first step, first thing first, as we know, step one, and then we'll talk about YP when it comes. So y double dash minus 2y dash plus y is 0 is corresponding equation r square minus 2r plus 1 is 0, r minus 1 whole square is 0, and that gives you r equals 1. Right. If r is 1, what is your YH? If it is repeated, C1 e raised to x plus C2 x e raised to x. Yeah. That's your YH, step 1 done. Now, when you go to step 2, the choice of YP and what functions or N, this is where you will talk about all the forms of Y. Okay, I wrote everything in green. Now let's swap the color, go to maroon. Okay. Compare this with A x power m e raised to lambda x. That will give you your A is 6, which is good. Your m is 1 and lambda is 1. Okay, so this is your YP. If lambda is equal to R1, R2, your R1 is 1, your R2 is 1. Both of them are same. Lambda is equal to 1, which is the same as R1 and R2. Therefore, you will go for n is equal to 2, right? That will give you n is equal to 2. So your YP, which was AX power n P M X e raised to lambda x, will become YP. Leave the A as it is, X power n, so that will be X square. If we are talking about X square, your PMX will be A1X plus A0. Follow previous week's content, how you choose PMX, right? There'll be two terms, you know, and lambda being 1, so E power X. This is my YP, right? A as it is, N is 2, as we have chosen N is equal to 2, right? Because it meets this criteria. PMN is a polynomial in X. Since you're talking about X square, it will be A1X plus A0. If it was X power 3, we'd have gone for A2X square, A1X and A0. I think this is one of the earlier question. And E power X, right? Okay, once you determine, again, be extra careful in choosing your YP, all this thing. Once that's done, it's fixed. Y dash, Y double dash, put it in equation, compare the left and right, find the unknowns. Okay? Right. I'll write my YP bit extended form because I don't want too many constant, right? Remember when you got C1 plus C2 minus C3 or 3C3 or something like that, we combine all the constant, call it some nice, easy to go for Y, C or something, whatever you like, right? Some other constant. So that's what I'm trying to do. I got my A1X power 3, AA0 X square, E power X. Right. Your choice. What do you want to call AA0 and AA1? Right. I'll go with B1 and B2. Right. You could have chose anything, C and D. Don't go for C. C is constant. D and E, E and F, whatever you like. Okay. I have chosen B1 and B2 e power. That's my YP, right? Okay. So once I got my YP, I need YP dash, YP double dash. Okay. Okay. YP dash, first derivative, UV dash, remember? Right? If you want, I'll write one more step. B1x3, B2x squared dash, e raised to x as it is, and B1x3, B2x squared as it is, ex dash 3b1x squared 2b2x e power x. This one as it is, e power x, yp dash. Okay. Once you get your yp dash, the next step is yp double dash. You can combine it if you like. Can we? We can. Combining it is good so that when you are doing double dash, you don't got so many, right? Why we can combine it? Because there is some x squared term which we can combine, right? Okay, let's combine it. We got a x3, x power 3 term. Let's write that one. 3b1 plus b2 x squared plus 2b2x. See, there is no straight method of doing it. I can't say that this is the yp dash. You do your way. As long as you are having yp dash, yp double dash, put it back in the question, you'll be fine, right? Okay, I'll have to write it in the next step. So bit plus and, okay, b1x3, 3b1 plus b2x squared, 2b2x. Now yp double dash. Again, the uv thing. I'll keep this one as it is. And differentiation of e raised to x is e raised to x. Okay, now this differentiation 3b1x squared 2 times 3b1 plus b2x plus 2b2 e raised to x. Again, combine it before you move to the next step. So it's a bit easier, right? There is no x3 term, only one. So b1x3. With the x2, you got this and that. So 3b1, that will be 6b1 plus b2x squared. Combine them. So 6b1 plus 4b2x plus 2b2 e power x, that's yp double dash. Right. Now, back to the question. Y double dash minus 2y dash plus y is equal to 6x e raised to x. Y double dash minus 2y dash plus y is equal to 6x e raised to x. You have to plug everything in here. Really, really carefully. Okay. Right. Again, I'm changing the slides a bit, plus up and down. B1x3. 6b1 plus b2x squared 6b1 plus 4b2x. 2b2 minus 2y dash. This is my y dash. Okay, so yeah, y dash, which was b1x3. 3b1 plus b2x square. 2b2x e power x. Sorry, this is minus 2. Yeah. See, when you flip this, you have to be careful of not making any mistake. Okay. Minus 2 here. That's what I was saying. Right? Plus y. What is our y? Y is few slides back. Y is b1x3 plus b2x square. E raised to x is 4x e raised to x. Right? 4 or 6? What was it? 6, sorry. Right. Now, the only term we will get is this one. So when you separate it out, start making it is equal to 0, right? So that doesn't affect us. So we got a x3, we got a x square, we got a x, and we got a constant term. We just need b1 and b2. So you'll have 4 equations, but you don't need most of it, right? So in order to simplify this, your constant term is 0, right? Just focus. See, here's the tip. You can do however you like. You'll have 4 equations. Agree with that? You will have b3, which is 0b 0x power 3. You'll have some x square. That will be also 0x square. The x will be equated. You'll have a lot of, okay, so this is your x square, right? This is your x power 3. This is your x power 3. This is your x square, right? Then you got the x term. That's your x term, right? And then you got a constant. Out of all this, in my opinion, you can write down 4 equations and compare and whatnot. In my opinion, we are only in need of 2 equations. Easiest one, the simplest one is the x power 3, because that's all b1, as you can see. That will cancel out, so you can't use that. But we can obviously use the b2 and then something else. Yeah. And just compare it, right? Okay, let's write down everything so what I'm saying will make sense. Okay, so b1 minus 2b1 plus b1 along with x3. Okay, now 6b1 plus b2 from here. When from the second bracket, you'll get minus 6b1 minus 2b2. From the third bracket, you will get b2 along with x square. And you will have 6b1 plus 4b2 plus 2b2. There is no x in the last thing. X. And the constant which is 2b2, that's it, is equal to 0x3, 0x square, 6x e raised to x plus 0. Right? This one got cancelled, so it's fine. We don't worry about it. B1 to B1, so you can't use it. You could have used it if it is not 0, right? We can't use it. Okay, let's simplify it one more step. This one, 6b1, 6b1 gone. Oh, this one also gone. So you can't use x squared. So you're left with only 2 equations, not 4. Good. This is 6b1 plus 6b2 x. 2b2 is equal to 6x e raised to x plus 0. Now compare them. So 6b1 plus 6b2 is 6. And the other comparison is 2b2 is 0. If your 2b2 is 0, that will give you b2 is equal to 0. Once you put it back here, your b1 is 1. So you got b1 and b2, and that's what we're looking for. So your yp, right, which was originally b1 x 3, b2 x square e power x, will reduce to yp is equal to b2 is gone. So b1 is 1, x3 e raised to x. After all this terrible y dash, double dash, lot of expansion simplification, yp turn out nice and simple. And therefore, your step 3, which is y is equal to yh plus yp. Yh was, see, everything has a e raised to x common. So c1, c2x, and x3. This is your y, or yg, or y, however you write. No initial condition, right? So you don't have to find out the value of c1 and c2. Okay? Now, how do you know it's correct? Right? So those who are keen of verifying the authenticity of your solution, why I'm mentioning it, you don't have to. But if you have spare time in the exam, in the assignment especially, right, I would insist of verifying whether your answer is right or wrong. Right? So you go for y dash, not big deal. Y double dash, put it back in a question, which is this one, right? And that should be 6x e raised to x, like 3-4 steps, but you have verified what answer you obtain is correct, full marks in the assignment, in the exam. In the assignment, you have abundance of time. So don't let it go that, oh, I thought it was right, but it didn't. You know how to know if it's right or wrong. Yeah? Please go for that one. Cool. Okay, since we completed almost all the example, we are coming to the last one, which is kind of combination of two and a difficult one, right? So follow it, pause your recording if you're watching it, and, do it step by step. Right. The first step, which remains the same thing, nothing new with the first step, right? So let's start with the first step. The corresponding YH part. So step 1, right? We write y double dash minus 3y dash minus 4y is 0. I think this is similar, a bit similar to what we had. Anyway, r squared minus 3r minus 4 is 0. R minus 4, R plus 1, R is 4, R is minus 1. Okay? So your YH, C1, e raised to 4x, doesn't matter if you set C1, C2, they are constant, they are known, so it's absolutely fine. Even if you swap them, doesn't affect your answer here. C2 e raised to minus, and lock it in. At least some marks for doing this step. Now, when it comes to step 2, is where you will go for, all these forms, right? So there is not a single set. I'll go back to the earlier slide. This one. There is not a single one which is a combination of exponential along with algebraic. This is only polynomial, constant sign, which is not here. This is exponential, exponential with cos, and polynomial, but not in addition, right? So this is a combination of these two cases. Okay, so the YP that we select will have to be in combination. So we'll have two separate YPs. You call it YP1, YP2. And that's why this is a bit complicated, right? Right. So for our YP, what I will have to do is separate it out. Okay, and talk to them individually. So let's my first F1x. For that, I will have YP. First, YP1 is 10 e raised to minus x, and F2x, which is 4x squared plus 2x plus. Right. Now, my R1 and R2, I call it R1 and R2. We have to have this condition. R1 and R2 are different? Yes. What is your lambda? What is your lambda that you have? We are talking about 10 e raised to minus x. So lambda is minus 1. Lambda is the same as R1. So we are meeting this condition. Lambda is not same as R2. So it's not equivalent to both of them. It's similar to one of them. So your n has to be 1. And that gives you your n is 1. Okay. And for F2 is just the polynomial function, right? So when you talk about your YP1, see what is your YP? Is this bit, right? YP is that bit, okay? There is no x term in your exponential part. So if the x term is not there, this wouldn't come. Yeah, okay. So simply PMX, yeah, okay. So, sorry, going further. So your Y, P1, one for the corresponding F1x will be simply AX e raised to minus x. That's your YP1, right? My YP2. YP2 is simple because I got an x square thing. YP2, you choose constant you like. I'm going for B, C, and D. That's my YP2. Okay, and my combined YP, which is the addition of YP1 and YP2, AX e raised to minus x, BX squared, CX and D, that's my YP. Once you got your YP, that's it. This was the only tricky part, that you had two separate. If they multiply, one of the form from the table applied. Since they were in addition, you have to split them up. That's your exponential. So one of the form, that's your polynomial second form, and combine the YP. Fine, we got YP. What is our next step? YP dash, YP double dash, put it back in equation, compare the coefficient, you'll get A, B, C, D, everything. And then, from there, you'll have your actual YP. Okay, right. So YP dash. UV rule here, rest everything is fine. So AX e raised to minus x differentiation is minus e power x. This is AX differentiation is 1. This is 2BX plus CD is 0. yp double dash. Again, a product rule here, right? This will become ax e power negative x minus a e power negative x, right? That's been done. Differentiation of this be a e raised to minus x plus 2bc is gone. This is my yp double dash. Okay, so I got yp double dash. The original question, hold your horse, y double dash minus 3y dash minus 4y is 10 e raised to minus x plus 4x squared plus 2x plus 4. I will substitute in the next slide so I can keep going from there. Okay, ax e power 9. Can I combine it? I can combine this two, isn't it? Yes, I'll combine it. Okay, so ax e raised to minus x minus 2a e raised to minus x plus 2b. This is my y double dash minus 3y dash. So I can just multiply this by, sorry, this one by 3. This is my yp dash. Okay, so minus 3ax e power minus x But if you want minus 3 outside, that's also fine. Leave it outside, if that helps. Sorry. So you take your time writing this one. Minus 3, y dash is this, minus ax e raised to minus x plus ax e power minus x, sorry, a e power minus x plus 2bx plus c. Right? Minus 4y. What is our y? Is this one, ax e raised to minus x bx squared cx e is same as the right hand side. Same e raised to minus x 4x squared 2x and 4. When you combine it in a way so it's easy to compare. Okay, so I'll use 4 things. So I got e power x here, e power x here, e power minus x, e power minus. There are 5 e power minus x terms. Combine them in one. Okay, then talk about x squared. So this is x squared, this is x squared. Straight away you got b is equal to minus 1 because there is minus 4 ahead, right? Then the x terms along with the x term, right? And then the constant bit. Right? So again, when you combine it, make sure you are taking care of the constant that's ahead waiting for them. Okay, right. So this is what it looked like. I will write e power minus x here. First step, ax minus 2a. Okay, plus 3ax minus 3a minus 4ax. Okay, now the x squared part. I'll just write plus and leave minus 4b inside. X squared. Then the x part. Yeah, so that's done. X part is from here. So I will write plus here. 2b times minus 3, so minus 6b minus 4cx. And there is a constant part as well, which is minus 3c minus 4d. If you want, what you can write 0x plus 10 e raised to minus x Why 0x? Because you got an x term and a constant term as a multiple of e raised to x. Okay, next step is comparing, right? This is a whole thing. I'll simplify it and compare it. Okay, how can I simplify it? Okay, ax, 3x, and 4x is gone. Good. We don't have to worry about 0x. Minus 2a, if you don't want, don't write it. Yeah, just write 10. Because now I realize, yeah, let's not increase it. So 10, right? So minus 5a is 10. Okay. Then minus 6b minus 4c is 4. You can write down equation 1, 2, 3, 4 if you want. Yeah. Minus 3c minus 4d is 2. Sorry. What did I miss? I missed something. Sorry, my bad. Minus 4b is 4. Minus 6b minus 4c is 2. And minus 3c minus 4d is 4. Okay, it's a whole chain. A is independent. You'll get B from here. Once you get your B, put it here. You will get your C. Once you get your C, put it here. You'll get your D. Right? Okay. So that will give me, first of all, A is minus 2. That's independent. That doesn't help with anything else. Yeah? A is minus 2. Right. B is minus 1. Right? Now, what is the next thing? B is minus 1. What we have, minus 6b minus 4c is 2. So 6 minus 4c is 2. Minus 4c is minus 4. C is 1. C is 1. Okay? That will help you with the next one. Minus 3c minus 4d is, what is that? That's 4. Yes, so minus 3 minus 4d is 4. So 4d is 7. Did I miss anything here? With a constant? I missed 2b, isn't it, from the first one? Yeah, so that 2b has to be here. 2b. So therefore that 2b has to be here. Yeah, see this part? As you can see, this one. 2b, c, and d. Right? Okay, so 2b. Oops. 2b. So that's like minus 2. Right? So that's like minus 5 goes and becomes plus 9. And d is minus 9 on 4. That sounds good. Perfect. We got A, B, C, D. That's what we needed, right? So finally, your YP, which is what we have it from earlier, AX e raised to minus X, BX squared plus CX plus D, plug in all the values. So YP is minus 2x e power minus X minus X squared plus X minus 9 on 4. That's your YP. And finally, your step 3, which is addition of everything, H and P. So YG or Y, which is C1 e raised to 4x plus C2 e raised to minus x minus 2x e raised to minus x minus x squared plus x minus 9 for healthy question. That's your final answer. You could combine e power minus x if you want, or leave it like this, no problem. It's already enough length. The only tricky part, like I said, was at the beginning where you had two separate YPs. where you talk about F1 and F2, just function X, function 2. Talk about take care when you talk about lambda and R1 and R2, pick the right case, and from there you combine and get your YP. Once you get your YP, it's just a normal question. Okay, so that comes to an end of today's session. There's nothing more I should add here. So thank you very much for watching the recording or attending live. If any questions, get in touch with me. Otherwise, I'll see you the next week. Thank you very much. Take care.